Hello, welcome to this tutorial. In this tutorial, we'll be looking at the linear inequalities in two variables. In our last episode, we've learned about linear inequalities in one variable. So by the end of this video, we should be able to understand the concept of linear inequalities in two variables. We should be able to solve linear inequalities involving two variables. We should be able to draw the graph of linear inequalities involving two variables. And we should be able to determine a set of points that satisfy given set of linear inequalities involving two variables. My name is Ademola Folarin. This video is powered by IOTA Virtual Learning. So let's start. In our last episode, we've explained the concept of linear inequalities, that it deals with having two expressions being compared to each other using the sign of inequality, using any of the inequality sign. So any of the inequality signs, whenever we have it in between two expressions, we are saying that is linear inequalities. We say linear inequalities in two variables now. This is formed when we have two expressions being related to each other using inequality sign, and this has two variables. So when we relate two expressions to each other in which these expressions have two variables, we say we are dealing with linear inequalities. Examples of that are what we have here: 2x less than 3y plus 4, 7x minus 2y greater than 9, 3x plus 4y plus 3 greater than or equals to 2y minus 5. So you will see that here we have two variables, x and y. So whenever we have two variables, x and y, in a linear inequality, such is linear inequalities in two variables. In solving this, we've established it in the last episode that we solve it just like we solve linear equation. However, when we are plotting the graph of this, whenever the sign of the inequality is greater than or equal to, that is, we have this, or we have this less than or equal to, the line graph that we are going to be using in that point, that is the line graph that is going to be used to represent this, must be a thick line. But when we have greater than or less than, the kind of line we use to represent this is always broken line. Remember, we've established before now that when it involves greater than or equal to and greater than or less than or equal to, these are inclusive inequalities. What are we saying? If we say x is greater than or equals to 5, it means 5 is part of the values that can satisfy x. So it starts from 5, 6, 7 and above. These are the values that x can take in this kind of statement. Now we understand it. Let's move on to solving problems. Here we have a question: draw the graph of the following linear inequalities. We want to draw the graph of the following linear inequalities. So for the very first one, we have 4x minus 3y less than minus 12. Yes, that's less than. So here, to be able to solve this, what we need to do is let this inequality assume equal sign. That is 4x minus 3y equals minus 12. Then we set one variable to 0 so that we can get the other variable, and we do the same for the other variable. So here we can say when x is equals to 0, this will help us to determine the value of y. Putting x to be 0, that becomes 4 open bracket 0 minus 3y equals minus 12. And this gives us minus 3y equals minus 12. Divide both sides by negative 3, y will be equals to 4. So here we have the point saying when x is equals to 0, y is 4. So this is a point. To get the value of x when y is 0, we say when y equals 0, we can determine the value of x to say 4x minus 3y is equals to negative 12. Remember, we say y is 0, so this place takes the place of 0. Then we have 4x equals minus 12. Divide both sides by 4, we have x equals minus 3. So for this, we are saying when x is minus 3, y equals 0. So we have gotten 2 points. Let's list out those 2 points that we need to plot. We are plotting the points 0, 4. That's 1 point. When we want to plot a straight line graph, we need at least 2 points. And the point minus 3, 0. So now that we have these points, we can then bring in our graph. We are going to plot these 2 points on the graph. So the very first, we have it as point when x is 0, y is 4. That's this point. When x is 0, y is 4. The other one, when x is minus 3, y is 0. So we are plotting this. Now we've gotten these 2 points, we then need to plot this graph. To plot this graph, remember, this is just ordinary less than, so we are going to be using broken line instead of a straight thick line. So let's join these 2 lines. These 2 points. Alright. Now that we've joined the 2 points, how do we then determine the needed region? The inequality sign in the question is less than. That means the region that we need is the less than region. So which is, it follows this part. This is the region that satisfies that inequality. Which means any point along this region satisfies this inequality. If you try, let's pick this point. This is point x is minus 3, y is also 3. When x is minus 3 and y is 3. If you try to put it in this equation, when x is minus 3, that's 4 times minus 3, that's minus 12, minus 9, that's 3 times 3, that's 9, minus 9 is less than minus 12. Isn't that valid? Yes, it's valid. We've been able to solve that part. Moving on, let's solve the second question. For the second question, we have 2x plus y greater than or equals to 6. So to solve this greater than or equals to 6, we assume the place of equal sign so that we can be able to solve the problem. So we say let x be equals to 0. When x is equals to 0, we can then find the value of y. That will be 2 open bracket 0 plus y equals to 6. Then y will be equals to 6. So we can say we have the point when x is 0, 0, 6. That's one point. We need to get the other point. To get the other point, we say let y be equals to 0. When y is equals to 0, it becomes 2x plus y equals 6. Remember y is 0. That will be 2x equals 6. And our x will be equal to 3. That's another point when x is 3, y is 0. So we have the points that we want to plot. The points are 0, 6 and point 3, 0. So this is what we are going to interpret on the graph. So on this graph now, let's interpret the points that we have, which are when x is 0, y is 6. This is the point. When x is 3, y is 0. When x is 3, y is 0. So these are the 2 points that will form our straight line. However, considering the type of inequality sign that is in our straight line, it is an inclusive inequality. So the straight line will be a thick line because it's an inclusive inequality. Our straight line will be a thick line because it's an inclusive inequality. Now, what are the needed region? The inequality sign says greater than or equal to. So the region that are greater than or equal to will be this region. These are the needed region for this. So any point along this region will satisfy the inequality given to us. Interesting. So we understand this now. We may have 2 or more inequalities given to us that we should determine the same value of x and y that satisfy those inequalities simultaneously. How do we then go about that? Let's take a problem in that line. Such as we have here. Draw the graph and shade the area that gives the solution set of the following inequalities. We are going to solve this inequality and draw a graph that will satisfy the solution at the same time. In doing that, let me try to divide this. Okay, so for the first inequality, y is less than or equals to 2. So this is very easy. Just set this inequality sign to equals to. That means we can interpret it as y equals to 2 when there is no x. So the point at this region is point 0, 2. There is no x value. The second one, the second inequality, where we have 3x plus y greater than 6. Remember, we say the inequality sign we assume equal sign so that we can get the value for x and y. So here, when x is equals to 0, what will be the value of y? It just become 3 open bracket 0 plus y equals 6. That means y is equals to 6. So when y is equals to 0, what will be the value of x? That becomes 3x plus 0 equals 6. X is equals to 6 divided by 3. X is equals to 2. So for this second inequality, we have 2 points which are 0, 6 point, that's 1 point, and the other one is 2, 0. So those are the 2 points that we are going to plot to get the line of this inequality. Then the last part, x minus 2y less than or equals to 4. So here we also say when x is equals to 0, so that we can get the value of y, it becomes 0 minus 2y equals 4. That becomes y equals 4 divided by negative 2. Y equals negative 2. So when y equals 0, what will be our x? That will be x minus 2 to bracket 0 equals 4. Then x equals 4. So for this, we've also gotten 2 points, which are point 0, minus 2 and point 4, 0. Now that we've gotten the points to plot, we can now bring in the graph. To plot this graph, we are going to have 3 different inequalities on this graph. 3 different inequalities on this graph. So for the very first one, for y less than or equals to 2, we have just this point, the point that says y is 2. Because it's an inclusive inequality, we are going to be demarcating it with what we call the thick line. So it's going to be a straight thick line. Let's not forget to label it. That's a graph of y less than or equals to 2. It's getting interesting, isn't it? Fantastic. So for the second point, we have the point when x is 0, y is 6. When x is 0, y is 6, this point. And when x is 2, y is 0, this point. So this will be done using broken line. Let's try to use broken line for that. Okay. Manage my straight line. Okay, let's say we have something of such. So let me try to use the right one. Using this. But let's have it at the back of my mind that is a broken line. It's a broken line. So that's why I use this. Then let's look at the region for the first line that we've drawn. What are the acceptable region? The acceptable region are region less than or equals to 2. Less than or equals to 2. So these are the acceptable region. The regions that are less than or equals to 2. For this, these are the acceptable region. For the second line, this is greater than. Greater than. What are the acceptable region? The region greater than. So something like this. These are the acceptable region for this greater than. Right? Or better still, we should leave those region now. Now that we already have the idea. Let's draw the third graph. For the third graph, this one I would also like to use. I will remove the straight line so that you can remember it's broken line. The third one, when x is 0, y is minus 2. When x is 0, y is minus 2. And when x is 4, y is 0. This is also inclusive. So because it's inclusive, we are going to be using thick line for this, in an inclusive inequality. Now, this is for the region x minus 2y less than or equals to 4. So if we are going to look at the region that this one says the regions that are less than or equals to, that means the down part, the lower part. The second one says the regions that are above, that means this part. While this one says the regions that are less than, this is this part. So if we are going to draw this graph clearly, let me extend the first one. So here now, this is the acceptable region for the three inequalities. Any value you pick in this region will satisfy the three inequalities. To test this, let's pick any value at this region. Let's say I pick a point, this point. Look at the coordinate of this point. X is 3, y is 1. X is 3, y is 1. That's 3, 1. Now let's try to look at it here. Here y is less than 2, isn't it? Yes, y is less than 2 because it's 1. Good. For the second one, put x to be 3 and y to be 1. 3 times 3, 9, plus 1, 10. Is 10 not greater than 6? Yes, it is. So that is also satisfied. For the third one, 3 minus 2 times 1, which is 2. That is 3 minus 2. We have 1. Is 1 not less than or equals to 4? Yes, it is. You can see that this point satisfies the 3 inequalities at the same time. And what are the solution sets? So all this region, the coordinate of all this region satisfy this, including this, the coordinate of all this region I'm pointing at satisfy the solution set that we have. However, this point does not satisfy it because it falls on non-inclusive inequality line. Only those who fall on inclusive inequality line can satisfy it. The one that falls on non-inclusive inequality line cannot satisfy it. So if you enjoy this, don't forget to subscribe to this channel for more interesting educational videos like this. Thank you.